make this a little cleaner for readability, since I'm not talking to myself. Even if I was, I want to be clear even to myself. Okay, so we have that. So now we're going to just do the very same thing. I'm just going to fill over 3 cells and replace my voltage with my current, the label, that is. All right. So hopefully you guys understand what I'm saying. So this is going to be, and I can just delete all of this. This is current. And I want this in amperes. And again, current. Amperes. And then again, current. Amperes. Okay, let's put those values in. So we have our first measured value, and I'm just going to go 14.1, and then this one is 27.1. Uh-oh, not Q. And then I have my uncertainty, which is 0.01. And then I have my first measured current. In this case, it's going to be 3.1, not point zero 0.01. E -3. All right. And then the second point is 6.178 E -3. Okay. And we want and those are 3 decimal places. So let's just go ahead and make sure we include that decimal place. Increase. And I only have 1 decimal place for the voltage. So the uncertainty here is 2E -3. Nope, -5. All right, there we go. All right. We don't even need the decimal places because we don't have them, so I'm just gonna go ahead and decrease those and just let it be that. Just trying to stick with the problem. And so now let's go ahead and calculate the resistance, the uh, the measured resistance. All right. So we know that it's just a slope, and we spoke of this a little bit earlier. And I'll just pull this over to the side here, and we could see the formula here. So the measured resistance, make sure you put your units at the top here, and our measured resistance is going to be equal to, and I'm going to use parentheses. It's quite important that you understand that the numerator is a parenthesis, the denominator has parentheses around it. Okay, so that is kind of like really important. So I'm going to have this, that's my second point, minus my first point, divided by my second current, minus, I didn't do that right. I need to put another parenthesis down at the bottom. So that's my second current minus my first current. Close that parenthesis, and this should give me my measured resistance. All right. I think that I will go ahead and make this just a number. Okay. And you'll see that my number is 4224.894. So these are really calculations. And now let's go ahead and do the uncertainty in the resistance, or the uncertainty in the measured resistance. And this is still going to be in ohms. So I'm saying measured, I'm just writing, I fill that over. So this is the uncertainty in the measured resistance. All right. All right, so there we go. So how are we going to treat this? Well, again, we are using the same idea that we used before, and that is actually it's a little bit different. So we are going to have, uh, so when we are looking at the uncertainty in this particular case, we have to use delta of delta V. So delta of delta V is going to be equal to, and yeah, it's going to be equal to the square root of delta V1 squared plus delta V2 squared. And I need to, um, and that's going to give it to us. So these are two independent measures. So why is this valid? Well, we have two independent measures in this particular case for the top. Okay. So we have to find the uncertainty in this first. We have to find our delta V sub m. And we also have two independent measures for this bottom one. So we're going to have to find the delta I sub m here. All right. So we're going to use these two. I'm going to go ahead and do, and I'll put the little m here, and I'll put delta m equals to the square root of delta I sub 1 squared plus delta I sub 2 squared. Now, that's all in well, and that's beautiful. But once we have this, we actually are going to have to use it in another equation for our delta R. Now, this is where it's similar to what we did before, and that is just going to be our delta V sub m over delta V sub m. And we're going to go ahead and square that plus delta I sub m. Let me not put the squared there yet. Over delta I sub m. Okay. So the first one was because we had two independent measures. We could still find we could still find the uncertainty in those two because we're using them in the beginning. Okay. And this is in our original document, our first document. So go back and reference that. All right, the student manual, the student lab manual. Okay. So let's go ahead and put this into Microsoft Excel. I won't close that all the way down, so I can leave it open. So we have the uncertainty in the measured resistance. So you could see, um, nope, that's not what I want. I need to insert a couple of columns. And so I am going to have the uncertainty in the, and now in this case, it's going to have to be the uncertainty in the measured voltage. And then I am going to have my uncertainty in my measured resistance. I mean, not resistance, current. So you can see that my units are off. So we know that this is just amps, and our voltage is going to be in V or volts. And voltage is kind of like a misnomer. We can use it, but voltage really, we're talking about electric potential difference. So voltage measures the electric potential difference. I almost don't like voltage. because it's the electric potential difference that we're measuring. All right. But we use it, So sometimes we're measuring current, we'll just say, well, what's the amperage? But I don't know if we talk that way in distance, but any two ways. All right, so let's go ahead and do this. We are going to use the top equation here for the first one. And so this is just going to be equal to SQ all right? And then, of course, it's going to be the power, all right? The power. Now we need to go ahead and find the uncertainty in the measured voltage. And this is going to be the power squared. So that's our first one. And then I'm going to say plus the power, okay, of this same uncertainty. And then I'm just going to say squared. And that's going to be the uncertainty in that voltage. Let's see if I can add some more decimal places. That's fine. Okay, so I'm going to do the same thing for the uncertainty of the power in the measured current. So here we have our measured current, and we again are going to have our measured current. Boom. All right. So as you can see, it's showing 0, but let's just give ourselves, we could either put this in scientific notation, and you can see that we're going to get something, we'll get some more of a value here, and I'm going to increase my decimal place. And so now we can find the uncertainty in the measured voltage. All right. Okay. So let's do this. This is going to be equal to, so now we have our uncertainty. So SQRT, and then we're going to have the power. Okay. So we're going to have the uncertainty in our voltage, and our measured voltage. And then we need our, did I do the measured voltage? I did not. So I'm going to do this divided by 27.1 and 14. All right. So, and this is going to be squared, of course. Not in there, though. Squared. I think that's right. Let me see if I get any errors. Oh, yep, I have some errors. So I don't need an extra parenthesis there. All right. But I would need, so this should give me an error as well. Okay, good. I need an extra parenthesis here. So plus power, all right? And we want the uncertainty in the measured current divided by the measured current. So you'll see that I don't have the change in the measured current. So that's this minus this, or the second measured current minus the first measured current. And then we're going to take this to the second power, close that parenthetical statement, and let's close the square root parenthetical statement. And we are getting an uncertainty in our resistance here, but we're not done. We actually have to multiply this times the measured resistance. See what we have here. I'm going to go ahead and make this just a number. Uh, decrease a couple of decimal places, and you'll see that we're ending up with 39.1. Okay, and that is it.